are from group 2, and today we're going to present the design of single piece 2/2-pole permanent magnet synchronous motor PMSM for project 2. And our lecturer name is Dr. Nurhamiza binti Muhammad Nasir. So before we're going to start our presentation, I will introduce all of our members. So our group consists of 4 members, which is Minur Ana binti Halim, Dormitory DE19059, Betty Hoy Yugli DE19076, Nurul Aisyah binti Azman DE19068, and the last one is Fatina Tira binti Muhammad Asri DE19050.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aisyah binti Azman. I will explain what is permanent magnet synchronous motor. First of all, permanent magnet synchronous motor is a device that designed using permanent magnets embedded in the steel rotor to create a constant magnetic field. The stator carries winding connected to an AC supply to produce a rotating magnetic field. At synchronous speed, the rotor poles lock to the rotating magnetic field.
So I will continue the advantage and disadvantage of PMSM. So as we can see, there are more advantage compared to disadvantage of the PMSM. So the advantage of the permanent magnet synchronous motor is low in torque ripple, is high efficiency and power density. Otherwise, is low in maintenance cost and low in heat generation. And the permanent magnet synchronous motor is consist for a small size. So for the disadvantage of the permanent magnet synchronous motor, the permanent magnet synchronous motors require a drive and is complex to the control system, and the cost is very expensive.
I will explain the application of PMSM. First of all, PMSM, the application of PMSM is in robotic, actuator, machine tools, industrial drive, and vehicular propulsion.
Hi, my name is Betty Hoy Yugli, metric number DE1900076. I will present on the design parameter table for our project and also the setting to our 3D model design. This is the table for our dimension value and also other parameters. The dimension value is the new calculated value using the increment of 5.2%. Now my partner will proceed to explain on the geometry model for the 2D design.
Hi, Assalamualaikum. My name is Fatina Tira binti Muhammad Asri. My metric number is DE1900050. So today I will explain about the 2D design and the result for 3D design. Okay, first of all, in 2D design, it consists of 2 parts. The first part is geometry editor and the second part is geometry designer. For geometry editor, we need to design each part of motor, which is rotor, stator, permanent magnet, and armature coil separately. So first of all, we need to design the rotor. So this is my rotor in the yellow color, and beside it the magnet in purple color. So then after we design the rotor and permanent magnet, we need to design the stator. So my stator is in blue, and the last one is armature coil. My armature coil is in green color. So after we save this project, it will appear like this. Next, for geometry design, in this part, it consists of 5 sections. So first of all, we need to set the materials condition, set the circuit, set the mesh and steady properties, and lastly run the project. Okay, first of all, we need to set the materials and condition for each part of the motor that have been created from the first part, from the table that have been given in the project instruction. So the materials and condition for each part of the motor, we can find it under the toolbox sections. After we apply the materials and condition, it will stay under the project manager. So this is the material that have been applied for each part of my motor, and this is the condition. After that, we need to create or design the circuit. Okay, as we can see, I already designed the circuit. So this is the circuit construction that have been given in the project instructions. For each part of the FEM coil, I set it with 10 turns, and FEM coil 2 with 10 turns too. After that, we go to the mesh, right click, and access control and pipe. At this section, we need to select all part of the motor. Okay, this is my part. Under the mesh again, click generate. And under the study magnetic, right click and go to the properties. Okay, at these properties, under the step control, we need to set the number of steps, end time and divisions. So the number of steps is 37, end time is 0.05 seconds, division is 36, and under conversions, we need to set the step length with 25 mm. And then click OK. Under the study magnetic, again run active case. After we run the active case, will appear the result under the graph. So this is my result for torque, FEM coil, and coil flood linkage. Based on the project instructions, it requires us to set the number of turns per phase into 10 and 20. So to create the 20 turns, go to study magnetic and click the duplicate study. Okay, after we click the duplicate study, it will appear like this and set again the circuit. Okay, this time set the FEM coil 1 and coil 2 with 20 turns and follows the other step before this. Result for 20 turns. This is the torque, coil flood linkage, and FEM coil inductance.
Now I will explain how we design the model in 3D. First step is to extend the model to 3D and change the extrude length to 25 mm, and then we click OK. I have done this. Now we click on the model. First step is to set the symmetry boundary. To set it, just drag the symmetry boundary from the condition to any of the face here, and then we select the front face and select all the face, and then the back face and select the face again. This is the list that I've selected, and then we click OK. Now we set the mesh property. Select extruded mesh and also slide mesh, and this is the model length. This is the property for our slide division, and then we click OK. Now we set the size control for the part. The first part is rotor, and then we repeat the same one for the stator. This one, then click OK. Now we set the mesh size control for face. Just click face, and then we set the air gap as shown here, the red line, and then click OK. Now we set the periodic mesh. Just click here. It will come out like this, and then we just change the title to automatic and then click OK. Now my partner will proceed to explain our result for the 3D.
This is the result for 3D design. So this is the result for torque, coil flood linkage, and FEM coil inductance.
That we got in this our project 2 is we have successfully designed and analyzed a single phase 2S and 2P permanent magnet synchronous motor PMSM using Geomet Designer and Geometry Editor. The flood characteristic of single phase 2S 2P PMSM is analyzed through the graphical result for FEM, coil inductance, torque, and coil flood linkage. The result obtained are affected by the number of turns in FEM coils, presence of magnetic dipole and monopoles, as well as the concept of Faraday's law of induction.